Intel draw a line in the sand to boost gross margin. New products must deliver 50% gross profit to get the green light. Lip-Bu Tan is laser focused on getting Intel back to maximizing shareholder value. When you Intel will not be entertaining any project that do not promise to double its money going forward. Michelle Jones, the Horthouse CEO of Intel Product, announced at the Bank of America Global Technology Conference that Intel is no longer approving new projects that cannot be proven on at least 50% gross margin based on a set of the industry expectation. Horthouse explained the Intel newly school adverse policy as something that we probably should have had before, but we have it now so that the product does not move forward. You actually don't get the engineer assigned to it if it's not 50% or higher gross margin moving forward. Horthouse also clarified that while Intel is not expecting or projecting 50% gross margin across all operations, its number in the company is aspiring toward internally. All of Intel's future roadmap operations, including Panther Lake and Nova Lake, are also currently expected to reach 50% gross profit number that the rest of the business aspire to. The drive behind this initiative is reportedly coming from the Intel's new CEO, Lip-Bu Tan. Tan is reportedly laser focused on the fact that we need to get our gross margin back above 50%. To accomplish this, Tan is said to be investigating and potentially canceling or changing unprofitable deals with other companies. The Intel margins have slipped to new lows for the companies in recent months. Microtrends reports Intel's trailing 12 months gross margin for Q1 2025 was as low as 31.67%. Intel's gross margin has hovered around 60% mark for 10 years leading up to the COVID-19 pandemic, falling back to 50% in Q2 2022 and continuing to steadily fall ever since. The Horthouse predicts a tug-of-war to ensue with Intel in the coming months as engineers and executives reckon with being forced between a rock and a hard place. We need to be a building product that fit the right competitive landscape and the requirement of our customers, but also have the right cost structure in place. It really requires us to do both. The CEO, Lip-Bu Tan, has done much to streamline the Intel's operation and ride a rocket ship inherited from previous Intel chief, the Pat Gelsinger. Another major round of the layoff, potentially up to 20% of the remaining workforce, is coming in Q2, arriving after a major leadership change up to remove middle management between Tan and other team leads. So the Tan is also quoted as wanting to turn Intel into the engineering-focused company again under his leadership. To reach this, Tan has committed to investigating in recruiting and retaining top talent. I believe Intel has lost some of this talent over the years. I want to create a culture of innovation empowerment, maintaining a culture of empowering innovation and top talent since its face and odds with the layoffs a lot on project not projected to grow 50% margin. But Tan seemingly has Intel investors on his side in this pursuit. Follow the Tom Hardware on Google News to get our optimism. Blah 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 blah. Okay. Then next one is which one is one of them? Okay, I think the giant reuse. Okay. Ex-TSMC executive joined Samsung Foundry to lead the U.S. expansion. The South Korean chip giant new U.S. Foundry head, the Margaret Han, worked for TSMC for more than 20 years. The Samsung Electronics company has brought the former Taiwan Semiconductor Manufacturing Company Ltd. TSMC executives on board to lead its North American the foundry operation, ramping up efforts to bolster its loss-making contract chip-making business in U.S. Earlier this year, Samsung Device Solutions America (DSA) and the South Korean the memory chip giant U.S. Semiconductor Unit appointed Margaret Han as the executive vice president to head its U.S. foundry business, according to the industry sources on Monday. So the Han previously served as the head of global external foundry sourcing and supplier management at Intel Corporation, following a 12-year career at TSMC, where she held roles in sales, marketing, and business development. She also worked at NXP Semiconductors, overseeing global procurement. Han's appointment comes as Samsung seeks to strengthen its position in the U.S. foundry market by securing large foundry orders from big tech customers such as NVIDIA Corporation, Tesla Incorporation, and Amazon.com Incorporation. The Korean chip company is currently constructing a $17 billion chip fabrication plant in Texas to boost its production capacity on U.S. soil. The plant product timeline has been pushed back 2 years to 2026. Han is expected to leverage her 2 decades of experience in customer relations and sales and TSMC to support Samsung's foundry business. Deep in the red, despite the years of investment to crack the dominance of TSMC in the global chip foundry market, Samsung contracted chip-making business to continue to trail its Taiwanese rival. As of fourth quarter of 2024, Samsung, the world number 2 foundry player, had 8.2% market share compared to TSMC's 67.1%. The division also posted more than the $2 trillion $1.4 billion in operating losses in the fourth quarter of 2024, elevating the annual loss to more than $4 trillion. Okay, the next one is quite old one. Intel announced a strategic investment by Silver Lake in Altera. Raghib Hussain appointed Chief Executive Officer of Altera. I think I already read it. Okay, this article. Through ways to raise to 3D ideas, Intel, Samsung, and the Samsung are developing a broad set of the technologies and relationships that will be required for next generation of AI chips. Intel Foundry, TSMC, and Samsung Foundry are scrambling to deliver all foundational components of full 3D ICs, which collectively will deliver orders of magnitude improvement in performance with minimal power sometimes within the next few years. Much attention has been focused on process node advanced, but I think we can you can read this paper next time. The Arrow Lake die shows off the details Intel's chip based design. The Arrow Lake might be slow in gaming, but the architecture is still a sight to behold under the hood. Die shots of the Intel Arrow Lake architecture have been published, revealing the Intel's chiplet tile infused design in all its glory. Andreas scaling the X shared several images of Arrow the lake up the close and reveal the layout, the Arrow Lake's individual tiles, and the layout on the cores inside the computer tile. The first photo exposes the full die of Intel's desktop Core Ultra 200 S-series CPUs with the computer tile on the upper left, and the I/O tile on the bottom, and the SoC tile and the GPU tile on the right. To the bottom left and the top right are two filler dies designed to prove structural rigidity. The computer die is fed on a TSMC bleeding edge and 3B node with a total error of 117.2241 square millimeter. The I/O tile and the SoC tile are fed on the TSMC is the older N3 and 6 old node with the I/O title ensuring the 12.475 millimeter squared, and the SoC tile is 86.648 millimeter squared. All of the tiles last on the rank based on its effect on Intel's 22 nanometer FinFET node. Arrow Lake is the first Intel architecture that fabricated entirely using nodes from a competitor, except for the base title. The next image shows all of the sub-components for the secondary tiles in the Arrow Lake. The I/O dies houses the Thunderbolt 4 controlling display 5 PCIe Express buffers and files, and the TBT4 files, and the SoC tile houses the display engine and the media engine, as well as the PCIe 5 buffers and the DDR4 memory controller. The GPU tile houses the 4X GPU core and X3 LPG Arc chemistry render slice. The final image shows off the Intel's latest core configuration for Arrow Lake, which are different from previous hybrid Intel architectures. For Arrow Lake, Intel opted for a sandwich the E-cores between the P-cores rather than putting them or in their clusters, alleged to reduce the thermal hotspots for 4 of the 8 P-cores reside on the borders of the two die, with the other 4 residing in the middle of the die. The 4 E-core cluster, which house 4 core each, are sandwiched between the outer and the inner P-cores. Just Chilling's die shot also exposed the cache layer for Arrow Lake, comprised of 3 MB of the L3 cache per P-core. There is 6 MB in total and 3 MB of the L2 cache per E-core cluster, with 1.5 MB shared between 2 cores directly. And interconnected bridges have 2 L2 cache clusters and their associated cores together, which is also responsible for connecting each core cluster to the link agent. The major upgrade Intel made with the Arrow Lake is connecting to the E-core cluster to the L3 cache shared by the P-cores, effectively giving the E-cores an L3 cache. The Arrow Lake is one of the most interesting but complex architectures to date, and the first from the company to bring a chiplet-style design to desktop market. That said, Intel's first attempt to add a desktop chiplet-based computers has not been well received. Due to the latency issues from the interconnect, which is responsible for connecting all tiles together. Intel is attempting to rectify the issues through the firmware update still its current implementation can't touch AMD's competing Ryzen 9000 CPUs such as 9800 X3D, and nor is it enough to even beat its on previous generation, fourth generation processors in gaming such as 14900K. So that said, the moving to the chiplet approach will afford will entail more ways to optimize this architecture down the road in more efficient manner. Each tile can be developed independently of others and built with the different nodes to improve yield, optimize the development, and reduce production cost. The next one is about this article. Programmable AI silicon would help meet AI workload demand. There is no doubt that AI is driving every Asian agenda, whether it is hardware, software, automation, or anything else. This was clear at last week's the AI Chrysalis Chronicles panel discussion at the end of the Silicon Catalyst Spring 2025's portfolio company update at the Computer History Museum. So in Mountain View, CA, where the panelists debated the energy demands posed by AI, but how they were optimistic and the silicon innovation would come to the rescue. But in what form will that rescue come? Well, here in the Antwerp, Belgium, this week, the CEO of IMEC, Luc Van Hove, will tell the ITF World 2025 conference that AI future hinges on hardware innovation and could very likely come in form of the programmable AI silicon. He will explain that as we head toward agentic and physical AI, hardware is going to struggle to handle the diverse workload in a performant and a sustainable way. And the problem is that indicating AI hardware takes significantly more time than writing algorithms, and the software guys will then supersede the hardware guys by the time silicon comes out. So the quoting from his blog, Van den Hove said, to prevent bottlenecks from slowing down next generation AI, we must reinvent the way we do hardware innovation. The challenge is that while simply adding brute compute power and data had done an excellent job for the first generation of large language models and the transformation generative AI toward reasoning the borders and workloads will become increasingly heterogeneous, and one size fit all approaches using just brute force compute may not necessarily be the right solution to the chain various workloads. This is because agentic AI, which focuses on decision making and is highly relevant for medical application, than physical AI, which focuses on maximizing embodiment and interaction with the physical world for robotics and autonomous cars, and requires myriad of different models. Each model serves a specific purpose and interacts with others, forming AI system, and can combining large language models, perception models, and action models, and some models require CPU and some GPU, and others are currently lacking the right processors. Suboptimal hardware. Van den Hove highlights what everyone is saying, that AI has already become the significant energy consumers, and the demand for resources is likely to continue growing the arrival of next gen AI. He said the root of the problem is that AI often running on a suboptimal compute architecture consisting of suboptimal hardware components for a specific workload for the algorithm need. Adding new, challenging workloads to mix will cause AI-related energy to use to rise exponentially. Making it even more challenging is the fact that an AI workload could change the overnight, instigated by a new algorithm. Quoting the example of DeepSeek, he said the algorithm moved quickly, but hardware problems are time-intensive, taking several years to achieve even minor improvement, or while production is increasingly complex and therefore expensive. Stranded hardware asset. This means that developing a specific computing chip for each model can't keep up with the unprecedented pace of the innovation in models. He also talks about the stranded hardware assets as the pace of the software development is clearly faster than the hardware development. He said, furthermore, the laws of the economics are not playing in hardware favor either. There is a huge inherent risk of a stranded asset because by the time the AI hardware is finally ready, and the most moving AI software community may have taken a different turn. And while some companies may have the deep pockets to develop their own custom AI chips, those are few and far between, since the answer lies in the innovative silicon hardware that is programmable, or Van den Hooft put it, silicon hardware should become most as codable as software is. This means the same set of the hardware components should become reconfigurable, and meaning you would only need one computer instead. That return to a sequence of algorithms. In fact, the software should become silicon. This is a very different approach to a current hardware innovation, which is a fairly tough process. And the below, Van den Hooft gives us as an image of what that could look like. He said, picture it. Rather than one monolithic state-of-the-art and a super expensive processor, you'd get a different co-working supercells consisting of stacked layers of semiconductors, each optimized for a specific functionality and integrated in 3D, and so memory can be placed close to the logic processing unit, thereby limiting the energy losses of the data traffic. A network on chip will steer and reconfigure these supercells so they can be quickly adapted to the latest algorithm requirements, smartly combining the different versatile building blocks by splitting up the requirement over different chiplets instead of designing a monolithic chip. You can combine hardware from the different suppliers. He concluded, with this reconfigurable approach, many more companies will have the ability to design their own hardware for specific AI workloads. It will boost creativity in market and open possibility for differentiated and make hardware innovation affordable again by agreeing on universally adopted standards like RISC-V, and software and hardware companies are getting and think and guaranteeing both compatibility and performance. He adds AI's future hinges on hardware innovation and gives the vast impact of the AI on all societal domains, ranging from the silicon drug design to sensor fusion in robotics and autonomous driving. And it is probably not exaggerated to state that our very future hinges on it. I'm a technology from ITF World 2025 begins in Antwerp, Belgium, runs from 20 to 21 May 2025. Okay, thank you. Next one is NVIDIA CEO Jensen Huang said the U.S. ban on AI chip export failure set the spread of the U.S. chips fighter to competitive advantage. Jensen Huang believes that the U.S. should diffuse each AI technique across the globe instead of stopping each rival from getting it. The NVIDIA's Jensen Huang has said in an interview that the U.S. bans on AI chip exports are failure and are having the exact opposite effect on the White House wants, in that it's pushing its Chinese rivals like Huawei to innovate and build AI hardware and could compete against each offering. According to the Financial Times, the chief executive of the one of the most valuable companies in the world is criticized Washington. This is well on the NVIDIA's H20, which is specifically built for China. Huang said that NVIDIA has a 95% market share in China in early 2021 at the start of the Biden administration, but today it has already dropped to just 50%, and an effect of the various bans and sanctions on the Biden and Trump governments have applied to China. However, this does not mean that China's AI industry is shrinking. Instead, many companies are turning to the NVIDIA's Chinese competitors. Many of these companies still haven't matched the NVIDIA's technology, but they're quickly catching up, especially as China realized that its reliance on American technology means that it can be cut off anytime. And that's why Beijing and several other Chinese institutions are supercharging their investment in AI chips. Aside from that, some of the biggest Chinese tech companies like Tencent and Alibaba have started purchasing locally produced AI tech, which is further fueling research and development of Chinese chip makers. So the idea of AI diffusion limiting other countries' access to American technology is a mission expressed exactly wrong, Huang said in the interview with Stratechery. It should be about accelerating the adoption of the American technology everywhere before it is too late. If the goal is for America to lead, then the AI diffusion did exactly the opposite of that. The former Commerce Secretary Gina Raimondo seemingly agrees with Huang. She was previously quoted as saying that holding back China's progress through the bans and sanctions is a fool's errand, and the investment in semiconductor manufacturing, research, and innovation should matter more. Aside from being ineffective, Huang also said the H20 ban will not just cost NVIDIA, but it will also mean that the US will miss out on a lot of taxes. It's cost enormously cost. Not only am I losing $5.5 billion, we wrote off the $5.5 billion. We walked away from the $15 billion of sales, and probably, what is it? $3 billion worth of taxes, said the NVIDIA CEO. The China market is about $50 billion a year, and it's not $50 million, and it's $50 million. $50 billion. It's not $50 billion. It's $50 billion. The $15 billion is like Boeing, not the plane, the whole company, to leave behind, so that the profits that growth with, the scale goes with that, the economic buildings that goes with that, the loss of the massive ecosystem is biggest threat to Akuda in long run. Follow the Times hardware and the news like that. Okay. Okay. Thank you for your time. See you next time.